Hello, Math 30-1. So this is going to be a ratio that's mostly reviewed from Math 20, where it's just reviewing how you find angle measures in degrees from primary trig ratios. But these questions are going to be when theta is greater than 0 but less than or equal to 360. So it's going to involve you guys, or at least that, it's going to involve you guys using the cast rule as well as making sure you find reference angles and so on. So the only thing to remember is that it is never a good idea to plug in negatives when you're trying to find angles. You're always going to find the reference angle, whoopsie, you're always going to find the reference angle and then use that to find out the rest. So I'm just going to jump right into solving some questions like you would have done in Math 20. You can follow that procedure there or the ones that you had from your Math 20 notes. But in the first question, it says complete the following. When is cosine equal to, and I want you to always watch restrictions. So between 0 and 360. So you have an angle of theta that must have a cosine value of minus 0.5. Well, using the cast rule, if I have an angle theta, that angle of theta must be in quadrants where cosine is negative, and that's clearly going to happen in quadrants 2 and 3. So if I draw that terminal arm, that's going to be in quadrants 2 and 3. So theta in quadrant 2 would be there, and theta in quadrant 3 would be there. That reference angle turns out to be, and I plug it in my calculator, second sine, that reference, second or inverse cosine, that reference angle turns out to be 60 degrees. And a 60-degree angle in quadrant 2 has a rotation angle of 120 degrees. And a rotation angle in quadrant 3 would be 180 plus 60, which would be 240 degrees. And I could put that 180 minus the 60 and 180 plus the 60 gets you in quadrant 3, right? So that's review of what we've done before. If I go to question number 2, this squared comes into play, and that's really important. For the same reason, if you remember this question, when somebody would ask you x squared is equal to 4, that would mean that x could be equal to both plus or minus 2. And that's a really important math concept. So therefore, when somebody says that sine squared is equal to 0.5, that means that sine squared is equal to both plus or minus the square root of 0.5, right? Now I'm still between 0 and 360 degrees, so when I consider what quadrant should this be in, I use my cast rule. What quadrants is this? Well, because it's both positive and negative, it could be in 1 and 2 and 3 and 4. I have 4 possible answers that it could be. I find out my reference angle for, and the reference angle turns out to be 45 degrees. And again, how am I doing that? I am going inverse sine, and I never put a negative in, inverse sine of the square root of 0.5, which ends up being equal to 45 degrees. I put that 45 degree reference angle in all of the quadrants, oopsie, 45 degrees, and I end up with theta being equal to 45, 135, 225, and lastly 315. And all was good in the land. Okay, so that's mostly a review of the things we talked about in Math 20. We carry on, and now what happens if we do the same thing? There are no calculator keys for cosecant and secant and cotangent. We simply have to rewrite it in terms of our primary trig ratios. So for example, if somebody asks me to solve cotangent, that means that 1 over tangent of x is equal to root 3. So if I just take the reciprocal of both sides, then that really means that if I rewrite this question in terms of tangent, the tangent of x is equal to 1 over root 3. And now I simply go through the same steps I have in all the other questions. That's obviously a positive value. Tangent is positive in quadrants 1 and 3. So there's my reference angle. I need to find my reference angle. My reference angle for 1 over root 3 turns out to be 30 degrees. And if I put a 30-degree reference angle in quadrant 1 and a 30-degree reference in quadrant 3, I end up with two possible answers of x equals 30 degrees and also 210, right? And complete that with the next two. Maybe you're ready to fly on your own. And again, all of our restrictions have been between 0 and 360. That's not always going to happen. I go to my next example, and again, I rewrite. So that means that cosine of x is equal to 1 over minus 1.2631. I know that that's negative, so quadrants where cosine's negative is going to be in quadrants 2 and 3. Need to find the reference angle in those two quadrants. I do find the reference angle, and my reference angle, don't put a negative in. I find out my reference angle to be, in this case, to the nearest degree. Okay, I watch my rounding. My nearest degree is 38 degrees. If I put 38 degrees in those two quadrants, I get x equals, so I put that 38 degree angle in quadrant 3 and quadrant 2, and I get x is equal to 142 degrees, but it's also equal to 218 degrees as well. Okay? Following through with cosecant. Cosecant is the reciprocal of sine, so that means if I take the reciprocal of both sides, sine is equal to 1 over 2.45. Again, it's positive, so I will put it in quadrants where sine is positive, so that's quadrants 1 and 2. I find the reference angle in each of those. My reference angle turns out to be 24 degrees. Right? My reference angle is 24 degrees. I put 24 degrees in those two quadrants, and I end up with angles for x equal to 24 degrees as well as 156 degrees. Okay? Rewriting them. So now we have some special cases. What happens when we get these weird questions where we've got 0 or when is cosine undefined? This is going to make even more sense when we deal with the unit circle, but we can still handle it right now. So continuing on, strange, a cosine theta of 0, but when you think of that, well, is that positive or is that negative? Well, I guess it's kind of both. So we'll consider all four quadrants, and we'll still do the same thing, because 0 could be really considered positive or negative, but the reference angle here turns out to be 90 degrees. When you take the inverse cos of 0, you get 90. And if you put 90 in all these quadrants, 90 here, 90 here, 90 here, 90 here, 90 here, you really only get two answers for theta, and that is 90 and, 270. Yay. Well, the next one is even stranger. So how could you get 1 over sine being equal to undefined? Well, that would only be undefined if the sine of theta was equal to 0, because if you divide by 0, it's undefined. So now you're really answering the question, when is sine theta equal to 0? So once again, we put it in all four quadrants. We take the reference angle of that, and the reference angle for sine equal to 0 is actually 0 degrees. And when you put 0 in each of these positions, again, a little strange, 0 degrees, we end up, angles of theta are 0 degrees, but also 180 degrees, and also 360 degrees. All right. So there are interesting kinds of questions. We carry on. We just want to make sure we finished up. We carry on to the next part. And again, we have a new procedure for finding angles and radians. And one of the ways to do this is just to do your answers in degrees and then convert them back. But I would rather you not do that. Let's just do this in radians, okay? What we have to do is really watch our restrictions. So first answer is 0 to 2 pi. Great. So we've done something like this before. Again, the fact that it's in radians, and it says I need to be the nearest hundredth of a radian, so I watch that restriction as well. So I put this in quadrants. I put this in quadrants where where's cosine's positive. So I use the cast rule. Cosine is negative, I'm sorry. So cosine is negative in quadrants 2 and quadrants 3. I then go and find my reference angle. And my reference angle here turns out to be to 2 decimal places, nearest hundredth of a radian, so my calculation radian, my reference angle, again, I don't put the negative in, I get a reference angle equal to 1.047, blah, blah, blah. So I'm only going to consider 1.0, it said to the nearest hundredth, so I'm only going to consider 1.05. 1.05. Therefore, if this is pi, my one answer for theta is going to be pi minus 1.05, and my other answer is going to be pi plus 1.05. What do I get for a final answer? I get 2.09 and 4.19. All right? So that's finding it in radians, okay, to 1 decimal place, okay, or 2 decimal places, right? And the next one, cotangent, is equal to minus 5 over 4. So that means that tangent theta is equal to minus 4 over 5. Now notice that the restriction is between 0 and pi. Okay, well, fair enough. I'm going to do my cast rule. This goes in quadrants where tangent is negative. And the only places that tangent is negative is in quadrant 2 and in quadrant 4. So again, I find out my reference angle. My reference angle for this turns out to be 2 decimal places again. So my reference angle is 0.68. Or maybe I'll keep it to 3 decimal places for right now. My reference angle is equal to 0.675. So I put it in 2 quadrants, but hold on here. This one is actually irrelevant because my restriction says I'm only allowed to go up to pi. So I can't really be in this quadrant because this quadrant here is somewhere between 3 pi over 2 and 2 pi. So that's too far. I can only go in quadrant 2. Therefore, my only answer for theta is pi minus 0.675, which ends up being equal to 2.47. And the only reason I was careful, we need to be careful that our rounding error, so I'll choose to round my answer at the end, all right? And the last thing is sometimes we're asked to do multiples of pi radians. We need to have exact multiples. The last question was talking about having it in terms of 2 decimal places. Most times when we have pi, they're actually asking us to put it as an exact value, okay? And so that's what's going to happen in these questions right here in our final segment here. In our final segment, well, what happens if I've got sine equals a half? If I was talking 0 to 360, we'd all be fine. We're still going to do the same thing as we've done before. I'm now going to say, well, I need to put it in quadrants where where sine is positive. So that's this quadrant and this quadrant. I look for my reference angle, and my reference angle is going to be, my reference angle here is going to be, if I was doing it in degrees, inverse, you get 30 degrees. But I'm going to do it in radians, and 30 degrees is pi over 6. So if I put pi over 6 here, and I put pi over 6 here, what does that make my answers? Therefore, theta is equal to pi over 6, and pi minus pi over 6 is 5 pi over 6. I'm just using fractions. 1 minus 1/6 is 5 pi over 6. Okay? You could also do your answers in degrees and then convert them, but I'm going to stick with just staying with my multiples of pi. How could secant be minus root 2? Well, that's because the cosine of theta is equal to minus 1 over root 2. My reference angle happens to equal, it would be 45 degrees, but now it's going to be pi over 4. I put it in quadrants where that is negative, and those are 2 quadrants, 2 and 3. I put pi over 4 there and pi over 4 there. Remember that this is actually pi, so in my head, theta is equal to pi minus a quarter and pi plus 1/4. 4 quarters minus 1/4. So this is really what I'm doing in my head. 4 quarters minus 1/4 is equal to 3/4 pi, and 1/4 plus 1/4, sorry, 1 plus 1/4 is 5/4 pi. Okay? And lastly, when is cosecant undefined? One of those weird questions. When is cosecant undefined? Well, we talked about that before. That's when 1 over sine is equal to undefined, and we did this question before. That's when sine theta is equal to 0, and that happens with the reference angle. Again, the reference angle for that is still 0, but when we put it, in this case, in all 4 quadrants, 1 and 2 and 3 and 4, when we put 0 in all those, 0 and 0 and 0 and 0, remember that in terms of pi, this is 0 and 2 pi, and this is pi. So my answers here are theta is equal to 0, pi, and 2 pi, right? And that's the end of the story, working with exact values in radians. You cannot have decimals, all right? We will see you tomorrow.